Welcome to Omega Virtual Learning. In today's presentation, I will talk to you about quadratic sequences. Please share with your friends, subscribe this channel, and hit the notification button. By the end of this lesson, you will be able to understand and know the features of quadratic sequences. You also know how to generate the general formula or the nth term of quadratic sequences. You will also be able to list the first few terms of quadratic sequences when given the formulae. And lastly, you will know how to apply quadratic sequence in real life or application of the quadratic sequences in real life. Quadratic sequences are sequences whose second differences between consecutive terms are the same. Let's look at an example to explain what I've just said. I have a sequence 4, 9, 16, 25, 36. I want to find the term-to-term rule of this sequence. So between 9 and 4 is plus 5, plus 7, plus 9, and plus 11. I call this the first difference. Let's go for the second set of differences. Plus 2, plus 2, plus 2. This is what I call second differences, and it's constant. You realize that for quadratic sequences, the second difference will always settle on a constant number. So the feature of a quadratic sequence is that the second differences will always be the same, constant number. Let's look at another example. This is a decreasing sequence. So the first set of differences, negative 2, negative 5, negative 8, and negative 11. That's the first set of differences. Second differences, we have negative 3, negative 3, negative 3. So this sequence also settles on negative 3, constant number, negative 3. So these two sequences are quadratic because the second differences are the same. Second differences are the same throughout. If you carry on the pattern, you will still have the same negative 3 throughout for the second one and plus 2 for the first one. Now, we're going to induce and deduce some formula from the general formula for quadratic sequence. The formula is given as an squared plus bn plus c. This is similar to quadratic expression, except that in place of x we have n. And like I said in previous lesson, we need n in the formula because n represents the position of each of the terms in the sequence. So an squared plus bn plus c is a general formula for quadratic sequence. I'm going to do a little bit of simulation here with expression and do another one with real numbers, match the two and create equation and form a general relationship that will help us work out quadratic sequence. Given this formula, I can use 1 to create the first expressional term. I can use 2 to create a second expressional term, and I can use 3. So let's see what will happen when I do that. So I'm going to generate the first 3 terms, but it's going to be in an expression form. Substituting 1 to the formula, our first expression will be a plus b plus c, so that's be my first term as an expression. Substituting 2, 4a plus 2b plus c, that's my second expressional term. And substituting 3, I'm going to get 9a plus 3b plus c. So I've now formed a quadratic expressions. I'm still going to use the same principle by finding the differences between the terms. And to find the differences, it's always the current minus previous, current minus previous. So 4a minus a, 2b minus b, and c minus c. And if you did that correctly, our first difference will be 3a plus b. Next one, 9a minus 4a, 3b minus 2b, and c minus c. Also, if you've done that correctly, you're going to get 5a plus b. Now, I need to go for my second difference. 5a minus 3a and b minus b. That will give me 2a. And my expressional sequences will settle on a constant 2a. If I carry on the pattern, I'm going to still have 2a throughout. Okay. Now, I'm going to do a real number sequence and compare the relationship. First set of differences. Second set of differences. So that's what I've got so far. Now you can see there's a pattern here. Position of 2a is plus 4. Position of 3a plus b is plus 3. Position of a plus b plus c is plus 4. Now there's a relationship between the two. So 2a is always equal to the second difference. So always 2a is equal to the number that you end up with as your constant difference. Always. 3a plus b is always the first term of the first difference. The first term of your first difference. And a plus b plus c is always equal to the first term of the original sequence. So all you need to do is to remember this expression in that format. You can easily create it and record the expression and equate it to your numbers. So let's work this out. 2a, we said, must be equal to the constant difference. So 2a must be equal to 4. So when we work it out, 2a equals 4, a will be equals to 2. Next is 3a plus b must be equal to 3. But we know a already computed as 2, and 3a is 3 times 2. So we're going to have 6 plus b equals 3. And to find b, our b is negative 3. And lastly, a plus b plus c must be equal to the first term 4. We know a already is 2, a is 2, b is negative 3. So we substitute that. 2 minus 3 plus c equals 4. Negative 1 plus c equals 4. So we know that c is equal to 5. So now that we know our a is 2, our b is negative 3, and c is 5, all we need to do is replace a, b, and c with the values that we computed. And that's our formula. So the formula for this sequence, 4, 7, 14, 25, and 36, is giving us 2n squared minus 3n plus 5. And you can double check to see. Let's work out 7. 7 is the second position. So n is equal to 2. 2 squared is 4. 4 times 2 is 8. 3 times 2 is 6. 8 minus 6 is 2. 2 plus 5, 7. It works. So let's work out the formula for 1, 6, 15, 28, and 45. Recalling our expressions. So we first do the first differences. Second differences settles on 4. And we know how to compute, and we set our equation. First equation is 2a equals 4. So a is equal to 2. Second equation, 3a plus b equals 5. But a equals 2. So 3 times 2 is 6. 6 plus b equals 5. And b is equal to 5 minus 6 that's negative 1. Last equation to set up is a plus b plus c equals 1. But a is 2, b is negative 1. Substitute them to the equation. We have 2 minus 1 plus c equals 1. 1 plus c equals 1, and c is equal to 0. So given the formula an squared plus bn plus c, a is 2, b is negative 1, and c is 0, we're going to get a formula of 2n squared minus 1. Let's try and see if that is true. Pick a term. 15 is the third term, so it's the third position, so n is equal to 3. 3 squared, 9. 9 times 2, 18. 18 minus 3, 15. It works. One last derivation of the formula. Find the first set of differences. Second set of differences. We link our equation. First, 2a equals negative 6. So a will be equals to negative 3. 3a plus b must be equals to negative 7. A is negative 3. So 3 times negative 3 is negative 9. And b will be equals to negative 7 plus 9, and that will be positive 2. And our last equation to form is a plus b plus c equals negative 5. A is negative 3, b is negative 2. Substituting them back into the equation, negative 3 plus 2 plus c equals negative 5. And we have negative 1 plus c equals negative 5. So c is equal to negative 4. So our formula will now be negative 3n squared plus positive 2n minus 4. How do we list the first few terms? So in this situation, we are to list the first 3 terms and then jump and work out the 20th term. So it's still substitution. We first substitute 1, 2, 3, and we substitute 20. Substituting 1, that will give us positive 2. Substituting 2, positive 3. Substituting 3, positive 6. Now we're going to substitute 20 this time. And that is 363 for the first one. Let's look at the second one. Substituting 1, we get positive 3. Substituting 2, we get 11. Using 3, we get 25. Then we're going to substitute 20. 1,181. Last one. Using 1, positive 4. Using 2, negative 6. Using 3, negative 20. And using 20, negative 870. All you need to be good at here is know how to substitute values into expression. That's all you're doing, substituting values into expression. Okay, now let's look at application of quadratic sequence. We want to see when people meet the number of handshakes that exchanges between them. So we have one person, 2, 3, 4, 5. So we want to sort of count the number of handshakes that takes place, and from that generalize and come out with a formula so that we can predict the number of handshakes for multiple number of people. Obviously, one person, there's nobody to shake hands with, so there's no handshake. 2 people meet, just 1 handshake. 3 people, let's see what happens. The green man will shake 2 people, and the pink man will shake the black man. So there are 3 exchanges of handshakes for 3 people. What about 4? Can you guess what that would be? Okay. The green man will shake 3 people. The pink person 2 people. And the yellow person 1. So if you count the number of handshakes, we have 6. 5 people. Now if you count all the number of handshakes for the 5 people, we have 10. So we've been able to use this to at least come up with the first 5 terms. Now by this simulation, we'll be able to use it to understand the sequence and even predict ahead 40 people, how many handshakes will be exchanging between the people. We can sort of work it out using this simulation. So first is to work out the formula for the n number of people. Okay, so now the question that we're supposed to work out is, what if we have 17 people? How many handshakes will exchange between the 17 people? We don't want to carry on, so we just want to have a formula. So first thing we need to do is to find the formula of 0, 1, 3, 6, and 10. We go through our principle of finding quadratic sequence. So our first set of differences, second set of differences. Okay, let's recall our algebraic pattern. 2a is always equal to the second difference. So 2a is equal to 1. So I know a is equal to half. 3a plus b is equal to the first term of the first difference. But a is half. 3 times half will give me 3 over 2 plus b equals 1. If I want to work out b will be, I multiply through by 2. So I have 3 plus 2b equals 2, and that makes it easy for me to work out what b is. So b is now equals to negative half. The last equation to form is a plus b plus c is equal to the first term of the original sequence. First term. But a is half and b is negative half. So I have half minus half plus c equals 0, and c is equal to 0. So these are my a, b, and c. So putting them into the formula a n squared plus b n plus c, I'm going to have a formula of half n squared minus half n, which is also equal to half n into bracket n minus 1. That is the formula for n number of people, the handshakes for n number of people. So if I want to work out 17 people, n represents 17, substituting 17 to the formula comes out as 136 handshakes. So with 17 people, there's going to be 136 handshakes. That's the beauty of algebra in predicting generalizing situations. That brings us to the end of lesson 2. I hope you've enjoyed it. Please subscribe, share with your friends, hit the notification button. Let's make Omega Virtual Learning platform a great platform for people to learn from. Thank you very much for watching.